we've got to convert this table into a cumulative frequency table. Now, if you knew nothing about cumulative frequency, I think you could probably still do this question table. The only difference is that this column here is all from 200. So if we're looking at 200 to 250, well, we're given that in the first table. Next, we are asked to say how many people have a wage between 200 and 300. Well, if we go back to the original graph, that's 200 to 300 includes both of these groups, doesn't it? So we add them together. And that's what we're going to do for all of the rows of this new table. 200 to 350 will be those. Yeah. 200 to 400 is all of those. And the word cumulative means to keep a running total, add up as you go along. No trick here, it's as it appears. So we just add them up. So crucially, the number will never go down. It might stay the same, but it'll never go down. So 5 add 10 is 15. And then we've got to add to our running total, we add the next one, which is 20. So that becomes 35. Then we add the next one, which is another 20. So that will give us 55. Next one is 15. So that takes us to 70. And the last one is 10. We can easily check if we've done it correctly because our total at the end should be the total number of people. In this question, we were told the total number of people is 80. Alternatively, we could add up the frequency column. So that's possibly the easiest part of this. But the rest of the question hinges on this one table. Now we need to know how to plot this. The way we do this is we take as our x-axis, and it's labelled. X-axis is wages, and the y-axis is cumulative frequency. So these values here will be my x values. Obviously, it's not those values because they're all the same. We would just have a vertical line of points. So it must be those values that we plot along the x-axis. Up the y-axis, we plot those points. So again, we're heading towards 3 marks here for adding up some numbers and then plotting the points on a graph. It's a really good way to squeeze out a few marks on a higher tier paper. So we plot the first point is at 255. So that will be here. Is that showing up okay? Yeah. Next one is 315. Now, when we join these up, if we join them up with a nice smooth curve, it's going to look like that. Something like that. Again, I was saying your sketch with a pencil on paper should be more accurate than mine on this iPad. What I can do on the iPad is draw these with straight lines. Now, technically, the curve should be more accurate, but straight lines are acceptable. So I don't like doing straight lines. I prefer a curve. I was taught this in a year in the time when straight lines would not be acceptable. The curve is meant to more accurately estimate the values that are in between the values that we've actually got a reading. But for the purposes of this tutorial, that looks a lot better than the curve I was going to draw. Juan says 60% of this group of people have a weekly wage of 360 or less. Is that correct? Well, let's have a look. These percentiles, I'm going to go into more detail what other questions might be asked here, but essentially you will be asked to find percentiles from the data. This one's asking for 60%. So to find the 60% percentile, we need to think about the y-axis. So 100% of the people are represented by this point here. So 100% of people earn this value or less. Yeah. So 100% of people earn 500 or less. Now, to find the median, we would go halfway and find that half of people are here, and that would be whatever that wage is. We're being asked to look at 50%, 60%, sorry. So what is 60% of, again, the total number of people is 80. So 60% of all these people, 80 people, will be 0.6 times 80, which is, this is a non-calculator paper, so we do have to be able to work that out. 0.5 times 80 would be 40, so then we just need to add on another 8, so that would be 48. So we're looking, and again, there are 3 marks available here, so the value 48 should be clear from your working, because you'll get a mark for identifying 48. Now, we need to read this quite carefully here. So the y-axis is nice, is behaving nicely, which is good. 1 little square is 1 person, which is great. It's not always that great, is it? Sometimes you have to divide into 3s and all sorts. So this is 45, 46, 47, 48 is here. And for any percentile at all that we've been asked to find, we draw a line horizontally to the curve, and then from that point we carefully read the value down here. Now the x-axis is using 10 small squares to go up by 50. So each small square will be 5. So so that value there is sort of between what 380 and 385. So it's about, you know, 381, something like that. This is approximate, you know. So it looks like roughly 60% of people earn 381 or less. So what was the question we were being asked? The question was 60% of the group have a weekly wage of 360 or less. So let's just double check. We haven't misread that. So yeah, so 360 would be here. And this would be another way to answer the question, would be to start at 360 and go the other way on the graph. But we can see that 360 is actually, see, it's less than 50%. It's not, it's 40 people is 50% of the people. And this is under 40. So yeah, so it's definitely not true what Juan says. It's interesting thinking about why he got that wrong answer. I think he's not far off. I think he's only made one misconception here. Obviously, they're not asking us what mistake he made, but it is interesting to think about it. He's gone for 360. I think it looks like he might have read this reasonably well, but he's misread the axis. Maybe he's maybe counted, you know, one of these big squares as equaling 10. Possibly, you know, it's not far off, is it? It's definitely over 350 and less than 400. But so we're not going to get 3 marks just from this line alone. That is our working though. Either this line, finding what 60% of people is, or this line, finding, you know, what percentage of people earn 360. You're often asked to talk about the quartiles. So Q1 is the lower quartile. Q2 is the middle quartile, which is also known as the median. And Q3 is the upper quartile. And those are the values that are quite useful because we often aren't as interested in the extreme values at the top and the extreme values at the bottom. We're often more interested in the middle part of the data. So that's what this does. It chops the data into 4 sections, and the middle section is like where most people lie. So in order to find the median, we need to go halfway up the y-axis. So this axis goes up to 80. Oh, okay, I'm using that. Yeah, this goes up to 80. So to find the median, we go to 40. Read that off. And we get this value here. So that is the median. If the question asks what the median was, we would be able to say it looks like it's halfway between two of those little squares. So we were saying each of these little squares was worth 5, wasn't it? So that's like 360. So it's about 362, maybe, something like that. And again, this is approximate because this graph, we don't know exactly what's happening in between these plotted points. I've just assumed that. I mean, we know it will be some sort of smoothish curve, but yeah, so it is an approximation. So it doesn't matter too much if we're not exactly right. This would be easier to pass if I'd used a thinner pen as well. So you want to use a really good sharp pencil for this. And then to find the quartiles, so just like the median, we went halfway up. To find the lower quartile, we go a quarter of the way up. A quarter of 80 is 20. So if we read this off there, again, I can see that I'm not being perfectly accurate here because I'm using quite a thick line. So you definitely want a thinner line. I'm sticking to the thick line for this demonstration because it's easier to see what's going on the screen. But yeah, you would want a hard pencil preferably. So this is the lower quartile. And there it looks like it's about, what, 312 maybe? And then for the upper quartile, we go 3/4 of the way up. So that would be 20 away from 80, which is 60. Read that across, down. And it looks like we've got, what, 416? Something like that. And that's the upper quartile. As soon as you draw a cumulative frequency curve, you should expect to be doing something like this. In this particular question, we didn't. We went up to 60%, but it was the same idea. Now, from the upper quartile and the lower quartile, we can work out the interquartile range. Range is the largest value subtracted minus the smallest value. So the interquartile range is the upper quartile minus the lower quartile. And that is another measure. That is another measure of range. Rather than telling you how spread out all of the data are, it tells you how spread out the middle 50% of the data are. And it's a better measure of spread because often the range is thrown off by outliers, isn't it? If we had one value, maybe there was a CEO in this in these data, and we had this one CEO who had a massive wage, so the graph went miles over here just because of the one guy who had a huge salary. That would mean the range was affected massively by this one piece of data. But that is an outlier. We might not actually be interested in that. So by just focusing on the middle 50% of the data, we can get a more reliable measure of how spread out the data is. So now, if we think about how we use this to draw a box plot, so a box plot is just drawn using these values. So the lower quartile forms the bottom of the box, the median is a line inside the box, and the upper quartile is the top end of the box in the box plot. The box plot is not finished, that's the box part of the box plot, but we also need the whiskers. So the whiskers will So we've ignored the extremes of the data, but we still want to capture that. So we need to show what the highest value and the lowest value in the data is. Now, we don't know for sure what the highest value in the data is because we just know that 10 people have a wage between 200 and 500. So we kind of guess, but potentially someone could have a wage of 500. So we're going to call 500 the um, the maximum value in the data. Often, if a question was asking us to draw the box plot, they would tell us specifically what the largest value was. Maybe it was 480 or something, and we could refine our graph then. And we draw a little line going out to the whiskers. Now, often the bottom part will be 0, but in this table, we didn't talk to anybody who gets less than 200. We're not interested in those people who get less than £200 a week. So definitely, the smallest possible value is 200. So, and the x-axis actually only goes down to 200. It doesn't go down to 0. This is the box plot. I'm going to show you another question which asks you about how we use the box plot. So this question isn't really asking you to analyze the data very much, but it's just asking how do you draw a box plot. Something is wrong in this box plot. So rather than plotting a cumulative frequency curve and then doing the box plot, this question is just giving you all the numbers that need to be put into the diagram. So something is not correct, and it looks like two things are not correct. So we're just going to have to check each value. So the least height should be 142. So in this box plot, the least height is this value here. Is that 142? Yeah. So again, we do need to be careful reading the axis here. And it's been very friendly. There are 10 small squares to represent 10 centimeters, so each small square represents one. So this value here will be 142, and that is what's in the table, so that's correct. The lower quartile is 154, which is this part here, so again that's correct. The median is 162, right, so that's incorrect, isn't it? She's plotted that at 161. So yeah, so we could say this part is wrong. Now, they haven't given us the upper quartile, but they've given us the interquartile range. So in order to work out the upper quartile, we need to take the lower quartile and add the interquartile range. So 154 plus 17 is 171. That's the upper quartile. Yeah, to get the interquartile range, you subtract the lower quartile from the upper quartile. So this, we're doing that, we're doing it in reverse, essentially. So the upper quartile should be at 171, and that is incorrect as well. The graph has plotted it at 172. We could stop there because we found two errors, but it is worth checking the final value, because we might have done something wrong here, and if we find there's something else is wrong with this range, that means that one of the errors that we identified before was incorrect. So if the range is 40, so that means 182, and that is 142. So 182 minus 142 is 40, so that is correct. I'm going to finish just by asking a question that could be asked. So let's say we have been given two box plots, and the other one looks like this. We could be asked to compare these data. And how would we compare them? Well, when you're talking about distributions, you're talking about spread and measure of central tendency, an average, So here we could say that on average, both of these distributions have the same height. The average height for both of these groups of people is the same. But we can see that the data is not exactly the same. One other thing is that the range of the values is roughly the same. If we measure the distance from the smallest to the largest, that's roughly the same in both distributions. However, the difference is in this box, isn't it? The interquartile range is bigger in this upper value. So although the averages are the same, the top distribution has a wider spread of heights. Yeah, on the bottom one, the heights are much more closely grouped around the median. Now, because I've only extended it in this direction, that's also made the data more skewed. Now, in this one, the data is slightly skewed. The median is down to the lower end it's down to the lower end of the box. That would mean if we plotted a graph of these data, it would look skewed slightly. It'd sort of look like it would have this long tail like that. Yeah, it'd be more skewed to the left. If the median was slap bang in the middle and we plotted the graph of the data, it would look more symmetrical like that. Okay, so we can talk about range of both datas, interquartile range of both sets. Both of those are talking about spread. And again, we would want to come back to the data itself, and we would say that people's heights are more spread out in the top data, and it's more skewed to the lower end in the top set of data.